Solving simultaneous equations graphically. Simultaneous equations are a pair of equations involving two or sometimes more variables, and they're solved at the same time. Now, if we have an equation like y equals x plus 3, there are lots and lots of different values of x and y which satisfy that. So if x was equal to 1, y equals 4. If x equals 2, y equals 5. X equals 1,000. Y equals 1,003. And there's an infinite number of combinations. And that's why whenever we plot those, it forms this nice straight line. And each point on that line, either as a whole number or decimal values, rational or irrational, they are all the points on that line. So there's an infinite number of solutions to that. But if we were to add in the second equation, something like y equals 2x minus 1, then what we have, again, we've got lots of different solutions here. So we have x equals 1, y will equal 1. When x equals 2, y will equal 3. When x equals 3, y will equal 5. And again, there are an infinite number of solutions there available to that. But there will be one point that is unique to both of those equations, and that is the solution that we're interested in. That's how we solve, or that is the solution to simultaneous equations. So what we're doing is we've got two different equations and we're trying to solve them to find that unique point. And graphically, what that looks like is the point of intersection. So if we were to draw the graphs of y equals x plus 3 and 2x minus 1, the point through which they meet is the solution to the simultaneous equations. So example 6, we can see that there are some have already been done for us. So on the part A, the lines y equals x minus 2 in green has been drawn, and y equals minus x plus 4 has been drawn. And to solve the simultaneous equation, all we do is we look at the point where the two lines meet, and we can see here that it's going to be when x equals 3, y equals 1. And we could give that as a coordinate 3, 1. In part 2, we're trying to solve y equals 2x plus 2 and y equals minus x minus 4. And again, they've been drawn for us. If we look to see where the point of intersection is, so the point where the two lines meet, we can see that's minus 2, minus 2. So the solutions are going to be x equals minus 2 and y equals minus 2. And again, as a coordinate, we could write that as minus 2, minus 2. Example B, solve graphically the simultaneous equations y equals 3 plus 2x and y equals x plus 5. Now, what we've got here, we need to draw these 2 points. And we've looked previously at a number of different ways in which we can do that. But the easiest way is to think about it in terms of a table of values. So if we do that for y equals 3 plus 2x, if we get x equals y, and pick any three values, we'll pick 0, 2, and 3. When x equals 0, we've got 3 plus 2 times 0. So 2 zeros are 0. 0 plus 3 is 3. When x is 2, 2 2's are 4. 4 plus 3 is 7. And when it's 3, when x equals 3, 2 3's are 6, plus 3 is 9. So we've got our coordinates there of 0, 3, 2, 7, and 3, 9. We can do the same for y equals x plus 5. We come up with a table of values. This time we're going to pick 0, 1, and let's do 3 again. So when x equals 0, y is going to equal 0 plus 5, which is 5. When x equals 1, y is going to be 1 plus 5, which is 6. And when x is 3, y is going to be 3 plus 5, which is 8. So if we try and plot these, I'm going to mark on my axes. So 0, I'm going to go up in 2s. 2, 4, 6, 8, 10 and 12, and that's my y-axis. On the x-axis, I'm just going to go in whole values, so 1, 2, 3, 4, 5 and 6. So we'll plot the black line first of all, so we start off at 0, 3, and then 2, 7, and 3, 9, and we'll join those up. So there's the line being drawn for us, and then we do the same for the blue graph, x plus 5. So it's 0, 5, 1, 6, and 3, 8. And we'll join those up. Example C, the equations for the sides of the triangle are 3y plus x equals 9, 3y equals minus 8, x minus 12, and y equals 2x minus 4. Find the vertices of the triangles using 1 square for 1 unit. So what we're going to do here first of all is I'm going to look at the graph, label my axes so I know what range of values I need my x and y to lie between. So I can say that the x and y values have to be between 7 and minus 7. So getting back to the equations. So if we start off with 3y plus x equals 9. So this is a good case where we should try whenever x equals 0 to find out y, and when y is 0 to work out x. So when x is 0, you've got 3y plus 0 equals 9, so 3y equals 9. Divided by 3, we get that y equals 3. So the coordinate would be 0, 3, which is on the graph, so that's fine. When y is 0, you get 3 times 0 is 0, plus x is x, equals 9. So we'd get the point 9, 0, but that's off our graph. So what we could do is we could just substitute any x value in. So if we were to say x equals 3, then we get 3y plus 3 is 9. So 3y is 6. So y equals 2, which is going to be the graph, so that's good. So our point there would be 3, 2. The next one is 3y equals minus 8x, take 12. Now it'd be good if this was in the form y equals mx plus c to use our table of values. So if we divide through by 3, we get y equals minus 8 over 3x minus 4. Do our table of values, x and y. And here it would be a good idea to pick x values that are multiples of 3 so that it's going to make life a little bit easier for our coordinates. So if we were to pick minus 3, 0 and 3, that would give us a good range. So substituting the x values into the equation, so minus 8 thirds of minus 3, well 1 third of minus 3 is minus 1. So minus 8 thirds is going to be 8. 8 take away 4 is 4. Minus 8 thirds of 0 are going to be 0. 0 take away 4 is minus 4. And minus 8 thirds of 3 is minus 8. Take away 4 is minus 12. Now that last point will be outside our range, but we've got two good coordinates, so we're happy enough with that. And then the last one, we've got y equals 2x minus 4. So our table of values for that, pick 3x values, say 0, 2 and 4. When x is 0, 2 times 0 is 0. 0 take away 4 is minus 4. When x is 2, 2 2's are 4. 4 take away 4 is 0. And when x is 4, 2 4's are 8. 8 take away 4 is 4. And we've got three coordinates there of 0, minus 4, 2 0, and 4 4. So if we plot the first graph, the first point was at 0, 3. We also had 9 0, but that's off the graph. So the other point we worked out was 3 2. And we can join those points up, the graph will look like that. The next graph then, the points were -3, 4 and 0, -4. We can join those up to form this line. And the last line had coordinates of 0, -4, 2, 0 and 4, 4. And joining those up, we get this line. And then what we have is the 3 vertices, so the 3 coordinates of the points of intersection, to be -3, 4, 3, 2, and 0, -4.